Last we left our space travelers, they'd been pulled into a black hole at the center of the galaxy.
What are we going to do now, Charlie? None of our instruments are functioning properly.
Well, Ed, it was trigonometry that got us into this mess, and trigonometry's gonna get us out.
Early mathematicians were concerned with measurement, length, height, angles, time. One of their inventions was trigonometry, which they used to measure triangles, lengths of sides, and sizes of angles. Trigonometry has also been used to describe phenomena that are periodic in nature. For example, alternating current. In this series, we'll examine a unit of angle measurement called the radian. Let's look at how radians measure angles. An angle on the Cartesian plane is formed by rotating a terminal arm counterclockwise, away from an initial arm which lies on the x-axis. If we continue the rotation through 360 degrees, we describe a circle. Starting again, the terminal arm creates angle theta, here. The initial arm is the radius of the circle. Let's call it r. If the length of this arc is equal to the length of the radius, then the created angle is 1 radian. This sounds complicated, but look at it without the axes. If the arc and the radius are the same length, angle theta is 1 radian. The measurement of an angle in radians is actually a ratio. Divide the length of the arc by the length of the radius. When the lengths are equal, the angle is 1 radian. Let's look at an example. If the radius is 3 units and the arc is 5, the angle is 1.67 radians. Now we'll work out how many radians there are in a full circle. The radius is r. We know the circumference is 2 pi r. The circumference is also the arc length of angle theta. Pi, of course, is an irrational number, approximately equal to 3.14. We defined radians as the length of the arc divided by the length of the radius. In this case, the arc is the circumference of the circle, or 2 pi r. So the number of radians is 2 pi r divided by the radius r, or 2 pi radians. Substituting for pi, 6.28 radians. We also know there are 360 degrees in a circle, so 6.28 radians must equal 360 degrees, and each radian must be 57.3 degrees. Let's look at that again. A circle with radius r has a circumference of 2 pi r. Radians are defined as the ratio of arc length, in this case the circumference, to radius length. The r's divide out, so a circle has 2 pi radians. But a circle also has 360 degrees, so 2 pi radians equal 360 degrees. Substituting for pi, 1 radian is 57.3 degrees. Now, look at a half circle where theta is 180 degrees. The length of this arc is 1/2 the circumference of a circle, or pi r. Let's substitute pi r into the ratio. The r's cancel out. And we find that there are pi radians in 180 degrees. This is probably the easiest relationship to remember. Now let's put this to use. We'll reverse the equation and find some radian equivalents for other angles. 1 degree equals pi over 180 radians. So 60 degrees would equal 60 times pi over 180 radians, or pi over 3 radians. We usually leave these values containing pi in this form and don't substitute in the 3.14. Let's try 45 degrees. Simplifying, 45 degrees equals pi over 4 radians. Once again, quickly, start with a circle, radius r, and circumference 2 pi r. The number of radians is arc length divided by radius, 2 pi r divided by r, or 2 pi radians. A circle also has 360 degrees, so 2 pi radians equals 360 degrees. With a half circle, the number of radians is still arc length divided by radius length. This equals pi radians. So pi radians equals 180 degrees. Let's look at a quick way of finding the length of an arc if we know the radius and the angle in radians. If the radius is 8 centimeters and the angle is 2 radians, we can find the arc length directly. (16 centimeters).
I just don't know what's wrong, Charlie. I'm trying to get a bearing of 90 degrees, but nothing's happening.
Well, Ed, maybe we should try using radians instead of degrees. With 180 degrees equal to pi radians, we can calibrate our instruments in radians.
It's working, Charlie. I can get a directional bearing of pi over 2 radians. That's just like 90 degrees.
That's great, Ed. But now that we've got our bearings, which way do we go?